Okay, get this in the right direction. Okay. Hey guys, what's going on? In this video, we are going to finish our conversation about example 8, I think it is. Whichever example, depending on what version of the notes you have. But this is the house on the hill problem. And it's a monastery at the top of a hill. And what I want you to imagine, so the monastery is kind of maybe like right up here. By the way, that's a place where monks live and do all their meditation. So we'll put a little flag up there. And what they want to do is they want to get people, they think it's going to be a nice tourist attraction. So they want to get people from this parking lot, like down here, and they want to get them up to the top of this hill. And they want to do it using what's called a funicular railway. And so, you know, I didn't know what that was the first time that I looked at it. So I looked it up, and this is what a funicular railway is. And it turns out that we have one of these in Colorado Springs, called the Pikes Peak Cog Railway. And it's something that it's kind of a different kind of railroad where they use cogs to be able to go up really steep hills. And so we actually have one of these in Colorado. And so check it out. All right, so they want to get people from the parking lot up to the monastery, and in order to work, it has to be at a certain angle, right? It can't be too steep. And so they're examining this place at x equals 50, and we don't know what that necessarily means, but it's a coordinate, and so it might be 50 meters or 50 kilometers away from the parking lot, but whatever it is, it's this point, and they want to know, is that too steep for that kind of railway system? So that's kind of what they're looking for. So first thing that it's going to ask us to do is find the derivative. So we're going to find the derivative. Okay, that should be pretty easy given the things that we've already done. So using the power rule, f prime of x, and we call the derivative function the gradient function. So we're looking at the gradient or slope at any given point. And this would be the gradient function. Then it's find the gradient of the tangent at the point where x equals 50. Okay, a couple ways to do this. First, obviously, we can simply plug in 50 into our equation, negative 0.04 times 50 plus 3.4, and we can use our calculator to do that, right? So let's go ahead and do negative 0.04 times 50 plus 3.4, and we get 1.4 equals 1.4. Or we can graph. Let's again, we're going to just do a zoom standard, and again, we don't see anything, so we're going to have to go back to our domains, and if we think about our domains, we're going to set our minimums to 0 and then our maximums to 160, just like we did in the previous video. So we're going to go 0 and 160. I think we made it 250, so let's do 250, and then we'll do 0, and let's do 250 again, and we'll go ahead and graph it, and there's our hill. Okay, so what we can do now is we can go second calc, and we did this in, gosh, I think it was 12.1 or 12.2, but we can actually use option 6, and it'll allow us to figure out that derivative at any point we want, and we want 50, so we're just going to hit 50, and again, notice how up here we say dy dx is equal to 1.4. So you can obviously do it the old school way, or you can use technology, whichever one you want. So 1.4, that is going to be our derivative, and let's label that as m, okay, because that's our slope. Now, use the coordinate, right? Use the x value to find the rest of the coordinate. So f of, let's see here, x, let's plug in our x. Let's put f of 50 equals negative 0.02. We're putting it in the original equation, so 50 squared plus 3.4 times 50, And again, this is something that we could do just mathematically, like using simple computation. We could do this. Or we can come over to table, and we can put in, I think we can just put in 50, or we can scroll down. There's a setting where we could get it to tell us exactly what it was, or to ask us to check it. So we're just going to go down, and we figure out that it is 120. So again, use your calculator or just simply do the calculations. So we do y, let's see here, let's make it f of x. F of x equals 1.4x plus c. And we're going to choose our f of x to be 120, and then 1.5 times 50 plus c. And again, this time I'm just going to use the calculator. You can use the graphing mode to be able to figure out what that is. But we'll just do it. 1.5 times 50 is 75. 120 minus 75 is equal to 45. So we see that C is equal to 45. And we'll put this in now. We have f of x. Well, actually, we already have it right there. Let's just erase the C, and we'll put in 45. Right? Okay, so that's the equation. Now, we are going to have one more video. I want to keep it separate, and that is to do the normal line. So we'll come back with one more video, and we'll look at the normal line.